All right, folks. So today's topic is continuing with the product and quotient rules. We're just kind of adding more to the pile of things that are our toolbox of things that we can do, or derivatives that we can do. So this is notes aren't too bad, but then when you get to the homework, it's kind of like what do I do now? This throws everything into the mix, and that's kind of the idea of calculus. Calculus is the end of the movie. So if you never take calculus, you kind of really don't see why we did all of the stuff up until calculus. So be prepared to try to apply all of the different moves that we've done up to this point. I mean, we're talking about the derivative rules, but we're also talking about simple things like distributing and taking x's from the bottom and rewriting roots. All of those are fair game. All right, so we have to now look and decide what type of rule we have. So overall, what type of rule is this? Well, what kind of problem would you say this is? This is an overall division problem, right? You've got something on the top, you've got something on the bottom. This is a division problem. So if I'm going to do a division problem, that falls into the category of the quotient rule. So to do the quotient rule, we follow this formula. So I'm going to identify my u's and v's first. U is equal to the top. V is equal to the bottom. Now I like to write my u's and v's and then go back and identify the derivatives. So what's the derivative of x? 1. What's the derivative of 1 plus cotangent? Okay, now what type of rule is this? This is what I mean. You've got to keep asking yourself, what type of rule are we talking about? This is what we would call a sum rule. And there's a sum rule means we just derive each piece of this. So I would derive 1. What's the derivative of 1? 0. What's the derivative of cotangent? All right, now that's back in our couple lessons ago. You might have to grab that worksheet out. At the top, remember we have that list of all the derivatives. Now I know right away that this derivative is going to start with a negative because the trig function starts with a co. So what's the derivative of cotangent? Negative cosecant squared. What do you think? All right, now I can apply the quotient rule. So that's u prime v, and I always like to write a little minus here to remind myself that this is the one where you subtract uv prime. So y prime would equal, so look, when I do u prime times v, I'm going to be distributing a 1. And so I'm going to try to cut out some of these steps here. I'm going to try to do some of this in my head. So when I distribute the 1, I'm just going to get 1 plus cotangent. Then it's a minus, and I've got x times negative cosecant of x. Can we clean that up in our head? Well, we'll write it out if not. So x times negative cosecant squared of x. Now remember, this is the quotient rule, so this is where you go all over v squared. 1 plus cotangent of x squared. So now it's cleanup time. So we try to put stuff together. We try to make things look as nice as we can. The only thing I would really try to clean up here is just this piece. I mean, I don't know what to do with 1 plus cotangent. If it was cotangent squared, I might look at my Pythagorean identities, but we don't have any of those. So I'm just going to multiply these two pieces together. So y prime would equal 1 plus cotangent of x. Okay, what's a negative x times a negative cosecant squared? A positive x cosecant squared x. Why couldn't I put those x's together? Because this x is inside of the cosecant, where this is just a free x. So it's basically like saying, what's x times y? xy. So what's x times cosecant squared would just be x cosecant squared. 1 plus cotangent of x squared. Now, if this was a multiple choice, they might expand the bottom. but I'm not going to expand it unless I have to. So I'm not going to distribute that 1 plus cotangent times another 1 plus cotangent, blah, 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 blah. All right, you try the next one. So look at it first and try to say, overall, what type of rule is this? And then once you figure out what type of rule it is, apply that rule. This is where it's good to check in with a friend or check in with me as we're going around. Where's the multiplier? Put the word out there. Good. So who's before the dot? That's your units. Who's after the dot? That's the dot. Oh, you just write it different. You had me confused.
So after you got
Yes.
the first y,
Yes.
you just cleaned up, and that's the answer.
Yeah. I mean, you just you could technically, once you get to count, you don't ever have to clean anything up unless it's multiple choice. And then you have to clean it up to see if your answer looks like their answer. You could stop here technically. But, I mean, that's such an easy cleanup. A negative times a negative is a positive, blah, blah, blah.
Got it, thank you.
Yippers. What's up, friend?
This
It's just like, yeah, you can't
oh,
really
it's
do it.
this thing?
Yep. And then you just plug and chug into the formula.
Oh, okay.
So as I was walking around, looked like everybody had it. So overall, this is a multiply. That means that I've got my u's and my v's. My u is 3x cubed. My v is tangent. Now, I like to write those out first and then go back and derive. I was noticing as I was walking around, people were doing the derivative as they go. That's fine. That's a power rule. That's a trig rule. And we said this was the product rule. So that's u prime v plus uv prime. What do you think? Plug and chug. F prime of x would equal u prime v. I can't put those together. Plus u v prime. I also can't put those together. That's the end of the game. What do you think? All right, you guys try the next one.
Yeah, I knew you were gonna. Didn't technically get me because I knew it was gonna. I knew you're gonna switch up. What do you want me to not say? Because I don't know if you did it. Because I saw it.
I got you. They were doing a while though.
Let's go. Come on. We're taping this for posterity. Generations of students will be watching this video.
Oh, you're recording?
You guys are the crowd. Yeah, this is going to be what I post in classroom.
So we shouldn't say something stupid?
Correct. Maybe I shouldn't have said anything with Aaron in here.
Yeah, you should probably kick me out.
Give me some tape.
How many years are we gonna use this? I can say hi to my brother.
You can shout it out if you want.
Ian, if you hear this, I don't know, do something, be better in life.
Oh, jeez. That's kind of heavy.
Wait.
I don't know if I can.
All right, did you guys get a bunch of trig functions with a bunch of parentheses and stuff like that? Here's what I did. And I know this is kind of sneaky because I set you up to do U's and V's and U's and V's and U's and V's. I did a rewrite. What's secant? What can you tell me about secant?
Is the inverse of sine.
Close.
Cosine.
Getting closer. He said the inverse. What should we say?
Reciprocal.
The reciprocal. So what's secant the same as? 1 over cosine, right? So I can rewrite this as sine of x over cosine of x. What's sine of x over cosine of x? Tangent. And so what's y prime? The derivative of tangent is secant squared. Wait. The point of this example was for you to do your U's and V's and to get all that stuff, right? I wanted you to do that. So if you did that, that's good. But I want to reiterate to you, if you can avoid these moves, you can avoid them by trying to clean things up first. So in other words, if you want to distribute first, you can sometimes avoid the product rule. If you want to rewrite your trig stuff, you can sometimes avoid the quotient rule. Now, just to prove to you that what you did was not incorrect, let's go ahead and you tell me what you got. Hold on, sorry. Y prime equals cosine of x times secant of x? Sine of x? Secant of x, tangent of x. What do you think? Does that look like what you guys got? What do both of those chunks have? Secant. So I'm going to factor that out. Is that okay? So I'm going to take out a secant. What does that leave behind here? Cosine. Plus, now, this is going to be sine. What's tangent? Sine over cosine. So when I do sine times sine over cosine, it's going to turn into sine squared over cosine. You buy that? What do we want to do if we want to add these two things together? Common denominator. What would make both denominators happy? A cosine on the bottom. So I'm going to give this a cosine on the bottom, and I'm going to square it on the top. What would we have on the top? You don't have to write this down. I'm just proving to you that it's the same thing. So what's on the top here? What's cosine squared plus sine squared? We know this. What is it? 1. So this turns out to be secant times 1 over cosine. What can you tell me about 1 over cosine? It's secant. What's secant times secant? Now, if this was a multiple choice problem, I guarantee that they would write their answer as secant squared. So you would have to do all this cleanup to get there. You're going to have to clean up at some point. Why not clean up at the beginning so that you don't have to clean up at the end? That's the point of this example, all right? So I know it's tough. All of the stuff that you've done since like 5th grade is now in the mix. Any of those moves are all possible, and you always want to look first and say, how do I do this? This is different than what we've done up to this point. In pre-calculus, everything's in nice, neat little packages, and each unit is its own little package. In calculus, everything is all mixed together. Everything is fair game. And so that was just this example is to remind you, if you can clean up first, save yourself some headaches, because you obviously all would have rather done this than this. All right, the last two examples on the front here, I want to talk about just proving to you that you can get the derivative to look very different in two cases, and depending on which rule you want to use. So I want to do this one using the quotient rule. And here's my little note. The derivative of e to the x is e to the x. Do you guys remember what kills e to the x? Not just log, but natural log. Now, do you guys want to know why it's called the natural log? Here it is. This is the moment that you've been waiting for and wondering, why is it called natural log? It's because it's the only function whose derivative is itself. Huh? So the rate of change of the natural log function of the e to the function is exactly e. So each point the slope at each point is exactly the same as the function value. I mean, you kidding me?
Yo, dude.
WT heck?
Is Keegan listening? He would be like messing his shorts right now.
Oh, excuse me. How? Keegan says.
There he is.
We'll talk more in person, Keegan, but that's why it's called the natural log. It's the derivative. Its derivative is itself. The only other function that does that is the zero function, which is really a boring function. The horizontal line at height 0 on a graph would same, but anyway, okay, let's get going. So we'll let that shock sort of wear off here. What type of rule would you apply overall? I know it says the rule, but which one would you look at and see? Quotient rule. So I'm going to use my U's and V's. All right. What's the derivative of e to the x? E to the x, my very favorite derivative. No derivative is easier. What's the derivative of 2x to the third? 6x squared. Now I'm going to apply my u prime v plus uv prime. Oh, no, this is a quotient rule. Gal, darn it. This is why you write little notes, Stucky. So this is f prime of x would equal u prime v e to the x times 2x to the third minus e to the x times 6x squared all over v squared. So to clean this up, there isn't really much we could do. This would be 2x cubed e to the x. We usually put the e to the x second. Uh-oh, did I mess up? Oh, I could have. Yeah, I could have. If you wanted to, you could factor it out. It doesn't cancel though, right? But if you want to factor it out, you could. That's probably the problem with doing that. It doesn't make your problem any nicer in this case because you're still going to have two unlike terms and nothing would cancel. So I'm going to leave it in there. Hold on. 2 squared is 4. Exponent is multiply. There we are. Okay, what now? The quantity. Yep, good job. Now, what do you notice everything has here? A 2 and at least 2 x's, yes? So my cleanup would be, I'm going to cancel out a 2 and 2 x's from each piece. So this would be x e to the x minus 3, we took away 2 of them, e to the x. Divide by 2 would be 2, and we took away 2 of them, x to the 4th. All right, now, the next one, a lot of kids prefer, the reason I'm showing these examples, the point of these two examples is a lot of kids prefer to do the product rule in comparison to the quotient rule. And I just want to talk about the price of turning something from the bottom to the top. This is old news. What does it cost to take something from the bottom and put it to the top? What's my rewrite going to look like if I want to do the product rule? F of x equals, what would be a negative? The exponent, but the exponent of who?
X.
Just x. So what happens to the 2 is it stays on the bottom. The point of this example is to remind you that when you bump something from the bottom to the top, you have to give it a negative exponent. So I don't want to bump the 2 from the bottom to the top. Now I'm going to apply the product rule this time. But I'm going to do the product rule without showing without my U's and V's. I'm going to show you guys a little trick here. You're going to try to do some of this in your head. What's wrong, Taylor? So you see what I did here? I had to leave this the same, e to the x over 2, but then I took this and I bumped it up. wait, shh. What?
I was just confused because the product rule, but then we use the quotient rule every time there's like a fraction.
Yeah. So my point is some kids hate the quotient. I hate the quotient rule because it's got that thing, that v squared on the bottom. So I'm showing you a trick of a way to turn a quotient rule problem into a product rule problem. You're going to get an answer that's going to be the same. It's going to look a little different, but it's going to be the same thing. Yes.
What about multiplying by the reciprocal?
So if I multiplied by the reciprocal, I'd have to take the x, I'd have to put this over 1. And then when I flip it, it would still be back on the bottom again. Does that make sense? Now it's tempting to take it and reciprocal it and then put it on the top, but that's not the reciprocal, right? You have to make it a fraction first and then you flip it and it still leaves you in exactly the same boat that you're in before. What do you think? All right, now I'm going to do this. I'm going to do the product rule without my u's and v's. I'm just going to do it in my head. So the product rule is u prime, so that would be this prime. So what's the derivative of e to the x? E to the x. So what's the derivative of e to the x over 2? E to the x over 2. So it's u prime times v. V is x to the negative 3. Plus u, which is e to the x over 2, times v prime. So if v is x to the negative 3, what's the derivative of that? Negative 3x to the negative 4. Good job. Now, my cleanup would just be putting this stuff back together. I would have e to the x over 2x cubed minus, right, because this is going to be a negative, 3e to the x over x to the 4th, 2x to the 4th. Now let's pause here and double check that these are actually the same answer. If I want to put these two fractions together, look at this first of all. You see the second fraction is perfect? Love it. Exactly the same as this. If I want to put these together, what would I have to get? I'd have to multiply x, would give this an x with dun 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 dun. So, you see it? What? Because when I do the derivative, I would get a negative 3, and a negative 3 times that positive would turn into a subtract.
I wrote it as plus and negative.
OMG. No, yes, it's fine.
Could you do it both ways for any of them?
Yes, that's my point. Is that if you prefer, what didn't I have to do here? Over v squared. And what didn't I have to do here? Remember to distribute the negative. So my point is, you can rewrite stuff to make it easier. Now, I don't care which one you did. Taylor said, I saw this as a division problem, so I would just do yes, that's what, awesome, good. My point is that these are the same answer. What do you think? All right, now the last bit, I think these are fun. This is what we call sparse information. I haven't given you anything except for these 4 pieces of information. The function g at 4 is 3. The function h at 4 is negative 1. The derivative of g at 4 is negative 2. The derivative of h at 4 is 5. And we need to figure out what f prime of 4 is. So I haven't told you what the functions are, but we can still figure out their derivatives. So, overall, let's go through. What's the derivative of f? Don't overthink it. What's the derivative of f? F prime. That's the best I can do here. Now, what type of rule is this? And when I say that, I'm basically asking you for 4 possibilities. Sum difference, product quotient. Those are the other 2. So is this a sum difference or a product quotient? Sum difference. So that means I just derive each piece. So what's the derivative of g? G prime. Minus, what's the derivative of h? H prime. Now, I can take this information and I can use the information they gave me to figure out what's happening at f prime of 4. So if I replace the x with a 4 here, I would replace the x with a 4 here. I would replace 8x with a 4 here, and now I can actually start plugging in some numbers. What is g prime of 4? Well, I look up above. They told me that g prime of 4 was negative 2. Minus, what did they say h prime was? H prime was 5. So what's minus 2 minus 5? Negative 7. I'm going to encourage you to take 10 seconds to talk to your neighbor, 15, 30 seconds maybe more like it. Talk to your neighbor, what the heck just happened? What the heck just happened? So can you find the derivative of something even if you don't know what it is? Yes, we just call it prime. F prime or G prime or H prime. All right, let's look at the next one. Again, what's the derivative of F? F prime. Equals. Now this is the part that you got to think with me. You've got to step back and say, what type of rule is this? There's 4 rules, but there's basically 2 categories. The sum difference rule and then the product quotient rules. The sum difference rules are awesome because you just derive each piece of it. The product rule or the quotient rule, you have to go and apply these rules. So is this a sum difference or a product quotient? This is a sum difference, which just means you derive each piece. What's the derivative of h? H prime. What's the derivative of 2? 0. Now I'm going to write it just so it makes sense in our notes. Now I can plug and chug. I'm supposed to figure out what f prime of 4 is. Well, if I put 4 in for this x, I have to put 4 in for this x. And they told me that h prime of 4 was 5. Turn and talk with a friend. What the heck just happened?
Yeah, about the first one.
Yes.
Yeah, where did the negative 2 and the 5 come from?
So that came from the sparse information that they gave us. They told me that g prime was negative 2. So where g prime was, I put in a negative 2. Then there was a subtract, and then it said h prime. Well, they told me that h prime was 5, so I put 5 in there. Well, it would be subtract because of the subtract in the middle, and then the 5 is still positive, and I put those together.
Okay, so could I skip all of that writing it out? If I can just see it in my head.
Yes, absolutely.
Fantastic. Because that's a lot.
All right, you guys try part C. And then we'll get into the complicated ones after that. All right, let's see how you did. So, what's the derivative of f? F prime equals. Now, step back, look at the problem overall, and decide what type of rule is it. Sum difference, product quotient. Sum difference, product quotient. Sum difference, which just means you derive each piece. So what's the derivative of g? G prime. What do you do when there's a constant? Guys, a constant is just a constant that just carries through. So what's the derivative of h? H prime. So what's the derivative of 2h? 2h prime. A constant is just a constant that will be constant forever. Now I can start to plug and chug. I want to figure out what's happening at 4. That means I can plug 4 in here, and I can plug 4 in here, and I can look up above. They told me that g prime of 4 was negative 2, plus 2 times, they told me that h prime was 5, so that's negative 2 plus 10, so that would be 8. What do you think? What do you think?
Just writing
What do you think?
that out is just.
That's the part that loses you?
Yeah, I can just see it easier.
I like it. All right. Now we're going to move on to the complicated ones. So we've got H over G. Is this some difference? Product quotient. Obviously, it's quotient. So I have to apply the quotient rule. Now I'm going to get a little lazy here. I'm just going to write this is U and this is V. So now I'm going to do the quotient rule over here. So what's the derivative of F? F prime. Now, don't be the kid that falls for this and just writes U prime over V prime. That's not the product rule. Even though up here, what did we do to this? Derived, and we were done. This is a quotient rule problem, so we have to follow the quotient rule. The quotient rule is U prime. Well, if H is U, what's U prime? H prime. U prime V, V is G, minus U, which is H, times V prime, which is G prime, all over V squared, which would be G squared. Now, if you guys want to, go over here and write your U's and V's, and you can still do it that way as well. But I'm going to kind of get to the spot where I don't want to write the U's and V's anymore. I want to do most of that in my head. All right, so now we can plug and chug. F prime of 4 would equal, okay, I'm looking up at my chart. H prime is 5 times regular G is 3. Subtract H is negative 1. G prime is negative 2, all over G, which is 3, squared. What do you think? So now I would try to clean this up. This would be 15. Negative times a negative times a negative is still negative 2. 3 squared is 9. 15 take away 2 is 13 over 9. You try the last one. Overall, what type of rule is it? Then go from there, applying the appropriate formula. Yes, I know, it's so annoying. I hate it too. I wish it was just prime. I think I got that. Yep. That rule is nice. Did you get 17? Good job. All right, let's take a look. So first of all, what type of problem is this? No, come on. What type of problem? Product rule, because it's U times V. Now, I wish it was just G prime, H prime. My life would be a lot easier. I deal with this a lot more than you do. Unfortunately, it doesn't work that way. So I have to follow the product rule problem. So, or formula. F prime of X then is U prime. So that would be G prime times V. This is the product rule, so it's plus U, which is G of X, times V prime, which is H prime of X. So F prime of 4 would be, they told me that G prime was negative 2. They told me that H was negative 1. They told me that G was 3. They told me that H prime was 5. So that's 2 plus 15 is 17? What do you think? Okay, now the homework set has all this stuff. It's complicated. It's not like just do what he showed us in the notes. You have to look at each problem and think, what kind of rule am I going to apply? And then apply those appropriate rules. Good luck.